Hi there and welcome to Magic. First of all, to my usual crowd, my normal subscribers on YouTube, I have to apologize because this video is probably not very interesting for others than software developers. However, since I intend to implement anarchy using Magic, it becomes crucial of me to actually document Magic, and more specifically Hyperlambda, the programming language that is the foundation for Magic. Simply because understanding Magic implies understanding Hyperlambda. And to understand anarchy, my direct democracy web server system, implies understanding Magic. So anyway, assuming you have installed Magic locally on your development machine, and if you don't know how to do that, there's a link in the description of this YouTube video to another video that explains you how to do just that. So anyway, after you have installed it, you can go to the evaluator. So this thing allows you to evaluate Hyperlambda. So what is Hyperlambda? Well, Hyperlambda is a programming language I've created myself. It's a DSL, domain-specific language, generically built such that you can create your own DSL based upon it. And this is actually the foundation for the CRUDification process, such that when I go here and I CRUDify, for instance, Magic off, CRUDify all of its tables, then what's actually happening is that Magic generates a bunch of files for me, and these files can be found inside of the files up here, menu item. Then you can open up modules, then you can open up magic_off, and here you can actually see the files that Magic generated for me. For instance, here is the users.get.hl, which is a Hyperlambda file. And this is actually the file that Magic creates for me during the CRUDification process. Now, users.get.hl has a very specific semantic name, implying it goes towards the users table inside of the Magic auth database, and it is a get HTTP REST endpoint pointing to an HL file implying Hyperlambda. So if I now go to the endpoints and I find show endpoints and I search for users and I find its get HTTP REST endpoint, as you can see here, then when I invoke this, what actually happens is that it actually evaluates my Hyperlambda file. So in order to understand Magic, obviously you need to also understand Hyperlambda. So let's start out with Hyperlambda 101. Now first open the evaluator here. The evaluator allows you to evaluate Hyperlambda. So first, what is Hyperlambda? Well, actually Hyperlambda is not technically a programming language. It's actually technically a file format, kind of like XML or JSON or similar types of file formats. YAML is very similar to Hyperlambda. And actually, the way it semantically works is that I can create nodes. It's basically just a hierarchical tree structure or graph object. Meaning if I write foo, then I write bar, then I write howdy. What I've actually done is that I have created 3 nodes. You might imagine these as XML tags if you wish, to associate them with something that you're probably acquainted with from before. Now, these 3 nodes happens to be in a sequence. Foo is before bar, bar is before howdy, etc. So if I now evaluate this, what actually the Hyperlambda parser will do, it will first parse a graph object consisting of 3 nodes for me. And then it will attempt to signal these in sequential order, foo, bar, and howdy, as if they were slots. A slot is a C# thing, and you can find an example inside of Magic in magic.backend, folder slots, and then folder version.cs, for instance. Here you can see a slot. Slot is basically just a C# class that implements the iSlot or the iSlot async interface, and it has an attribute with a name property. And the name property, this part here, version, effectively becomes the name of the slot that the Hyperlambda evaluator will try to raise. So if I now write version, and by the way, notice as I press the end, the color of my text changes. That's because it contains syntax highlighting and auto-completion and everything. In fact, I can do VER, click Control Space, and it will allow me to auto-complete my Hyperlambda keyword. If I now execute this, it will return this value. By the way, this is wrong. It's supposed to be 5.8.0. Now, so this basically allows me to create graph objects. And if we go back to foo, bar, howdy, well, none of these nodes have any attributes at all. However, if I, behind the bar node, type a colon and then hello, what I've actually done is that I've given my bar node a value. So bar is the name of my node, colon separates the name and the value, and hello is the value of the node. If I go back to my slot now, you will see that here I'm given a node. A node is a really cool class. Node happens to have, if I do input, it happens to have value, it happens to have name, and it happens to have children collection. So if I now create my own slot, let's copy this guy for simplicity reasons, and then let's call this guy foo. Then let's rename the class to foo. Then let's rename its name here to foo. And then I can actually, from inside of here, I can actually reference arguments. So if I assume there are two arguments, arg1 equal input dot children dot where, or first, pull in link here. First x dot name equal arg1. Okay, dot get ex. We pull in magic.node.extensions. String, and there we are. I'm now actually retrieving the value of a children node of the foo node that is given to my method here, signal implementation method, as its input node. So if I now write foo, 3 spaces, very important, 3 spaces basically means you're opening up the children collection, arg1 colon hello. And then I can create multiple arguments, arg2 word. Okay, so I'm now passing in basically 2 children nodes to my foo slot invocation. If we now go back here, and then we do the same, but instead we are extracting arg2, and then we can do input.value equal arg1 plus arg2. If I now recompile this thing, Control Z, and then I start running it again, several things will have happened. First of all, I now have an additional slot called foo, which I can actually invoke from my Hyperlambda as if it was a method or a function, if you wish. And it actually binds to a C# class, passing in both the value of foo here, in addition to its children as arguments to my method invocation. And in fact, if we now refresh this page, the evaluator, and we click Control Space and we type foo, you will see we now have a new slot. Okay, so let's invoke our slot foo, and as you can see here, the C# code extracts argument 1, argument 2, then it concatenates them and separates them by space, effectively resulting in that this should become hello space word, and evaluate, and there we are. And it returns its result as the value of the foo node. Now compare the foo first line down here carefully with the first line up here. You see now all of a sudden our foo node has been actually given a value being the sum of its arguments. And of course we can modify a collection any ways we wish. We can do input.clear. Now stop the backend and run it again, which will trigger a compilation. And then we go back here. We wait for it to finish and we evaluate it again. You will notice that arg1 and arg2 is now gone. They no longer exist. So this allows us to dynamically, during execution of our Hyperlambda code, actually modify the graph object that actually is the Hyperlambda code. In such a regard, it is similar to XSLT, if you wish, and it also actually has its own XPath, similar types of expressions too, allowing me to reference nodes. So let's reference nodes. Well, instead of invoking it directly, we can do arg1 hello.arg2 world, and then we can do x colon alpha.arg1 x colon alpha.arg2. This actually results in more or less the exact same result. However, instead of actually statically typing our values into the arg1 and the arg2 nodes, we are now actually referencing arguments in other parts of the tree. And since we are using the method on our nodes that is called getEx, it will actually dynamically evaluate that expression, and instead of actually returning this value, x colon alpha.arg1, it will evaluate that expression and return the result of the evaluation of this expression, effectively resulting in the exact same results. And let's refresh the page, because there probably won't be enough changes for you to realize that it actually did evaluate. And then let's evaluate it. And as you see here, the result is the exact same. This allows us to use this syntax starting with a dot as the name of our nodes to be used actually more or less like arguments in a traditional programming language. So that is the basic Hyperlambda 101. And actually one of the new features I have in version 5.8.0 is that I also have a Snippets library, allowing you to very easily and rapidly have a look at some of the more common snippets. For instance, if I want to send emails, I can do mail.smtp.send. Here is a slot called mail.smtp.send, which actually allows me to send an email using these credentials. And actually, if you open up your Google Gmail account for so-called insecure apps, very bad naming by the way, then you can actually just simply provide your username and your password here, and you'll be able to actually send an email over your Gmail account's SMTP server using this structure from Hyperlambda. Now, of course, if I evaluate this now, it's not going to actually work because this isn't my email authentication username and password. However, you get the point. Now, the snippets guy also has a lot of cool things. If you find a POP3, for instance, okay, this one allows me to fetch emails from my POP3 account, similar to the SMTP email. If I now select all of this text and I simply delete it, then I can do type if. If happens to be a keyword, but it's also a snippet. So if I hold down the Alt key on my keyboard and then press the I, Alt plus I, ta-da! If I do the same with the word while, Alt-I, ta-da! If I do the same with mail.smtp.send, Alt-I, ta-da, etc. So it actually dynamically injects the piece of code from the snippets that happens to have the same name. And most keywords, if you wish, in Hyperlambda actually have a snippet like these, most of the more important ones at the very least. So let's try to do something cool. Let's load a snippet in its entirety. If I click load, it's going to replace everything in my evaluator. Let's do MySQL something. Okay, MySQL reads. Here we are opening, we are signaling magic.db.mysql.read, and we're opening up magic_auth database. We are using the table roles. We can remove arguments. We want to have the name and the description from that database table. If we evaluate this, ta-da, here's all my 3 records in my roles database. And this allows me to do extremely huge amounts of functionality with an extremely small amount of code, which obviously has huge benefits when you're creating something such as, you know, anarchy or CRUD, REST endpoints, etc., etc. And actually, if you're curious about the what you can actually do, you can click the I here, or if you want to, Alt Q for that matter. This will give you a keyboard shortcut map for the Hyperlambda snippets evaluator. In addition, it will allow you to select the module here. For instance, if I'm interested in what I can do with a project called magic.lambda, I can select it. This will dynamically load my readme.md file for this particular project. As you can see here, the build is passing. And it will actually show me what I can do using this particular project with lots of example codes, etc., etc. Here are every single keyword in Hyperlambda documented downwards, and I can do the same for every single module or component or plugin or whatever you want to call it that Magic actually contains of. Here I have, for instance, magic.lambda.io. Okay, this is the way I manipulate files using Magic. And let's actually do that just for an example. Okay, we have a file here called urlresolver.hl. Evaluator io.file.control space load. Okay, what was its name? URL resolver. URL-resolver.hl. Control F5, ta-da, and it loaded up my file dynamically using Hyperlambda. Now, if you want to have a look at what you can actually do with Magic, the best place to start is actually the GitHub project website, github.com/portaguy/magic. From here, you can find the entirety of the documentation for the system down here. And there's a link in the description of this YouTube video to this particular GitHub project page. And here you can check out Magic Node, check out Magic Lambda, Magic Math slots, dynamically creating slots, how to manipulate strings, how to read and write files, how to invoke HTTP REST endpoints, how to use your Microsoft SQL Server database, MySQL database, emails, MIME parsing, JSON parsing, configuration accessing, logging, authentication and authorization using JWT tokens, crypto, slots, scheduler, Hyperlambda and validators, in addition to the C# documentation for these supporting libraries, which are pure C# libraries. If I go to any one of these, for instance, here's Magic Node, you will see the entirety of the documentation for this particular project. And this is probably the most important feature in the version 5.8.0. And yet again, it's important that you download actually that specific version to gain access to these features that I was demonstrating in this video. So anyway, that was it for today. Thank you for watching. Have a nice day.